Hey, I'm Nav, and today we're going to be talking about the environmental and economic benefit of switching from coal to natural gas-fired power plants. Let's narrow down our scope and look at this issue only in the United States. This is a flowchart of our presentation today, and what I'll be covering is the current position of the coal market, and I'll give you some statistics so as to explain why it's going to decline. We'll move on to an economic analysis followed by an environmental analysis, and then we're going to talk about how this could be implemented in today's climate. So what is coal? Coal is a fossil fuel and is the altered remains of prehistoric vegetation that originally accumulated in swamps and peat bogs. The energy we get from coal today comes from the energy that plants absorbed from the sun a million years ago. The way coal-fired power plants work is that coal is put into a boiler and burned, which creates steam. This steam is highly pressurized and is sent up to a turbine, which in turn works a generator, which creates electricity. Something pretty interesting about the process is that this steam is later on condensed and sent back to the boiler so as to improve the efficiency of the process. So this is a typical coal-fired power plant. Something that's pretty interesting is that the majority of the coal used in the US is used to generate electricity. According to EIA.gov, 92.8% of the coal consumed in the US was used purely for produce electricity. 50% of the electricity in 2008 was produced as a result of coal. However, in 2016, coal accounted for only 30% of the electric production in the US. That 30% was the lowest share of all time. And it goes to show the decline in the industry and how we're progressing towards alternate sources of fuel. So, like I said, the coal industry has been in decline for a couple of years now. The production of coal in 2016 was 782.2 million short tons, whereas in 2008 it was 1,172 million short tons. This is a 37% drop. The average number of employees in 2016 was also down to an all-time low of 50,500. As you can see from the graph over here, the amount of the electricity generation from coal was steadily increasing until 2008. However, in 2008, it dropped due to things like government policies and alternate sources of coal. So, there are a couple reasons for this drop or decline in the coal industry, the main one being environmental regulation. The Obama administration had policies in place that made it hard for coal to be produced, i.e. made it more expensive, and also resulted in a lot of lost jobs in the coal industry. Currently, under the Trump administration, this policy has been lifted, and the industry is getting slightly better, but it's definitely still an uphill battle. On top of that, a lot of capital has been introduced into the industry, and that's been replacing workers due to higher efficiency despite the cost, because the machines perform the task so much better. The discovery of alternate sources of energy has also been key in the decline of the coal industry. Things like fracking, for example. A cumulative combination of these factors has resulted in the future of coal being seen as financially risky because no one sees it progressing or going anywhere in the future, which is why people are hesitant to invest and industries become quite stagnant. Let me talk to you about the adverse effects that coal has on the environment. Burning coal releases toxins. Coal contains sulfur and other elements, including dangerous metals such as mercury, lead, and arsenic, that escape into the air after coal is burned. Burning coal also creates a lot of air pollution and health dangers. Burning coal emits large amounts of carbon dioxide. Coal is composed almost entirely of carbon, so burning coal unleashes large amounts of carbon dioxide into the atmosphere. These emissions have been shown to increase the greenhouse effect in the atmosphere and lead to global warming. Lastly, surface coal mining damages the environment. Mountains and mining is used to access layers of coal buried deep within the mountains. The mining techniques alter the landscapes and destroys these environments. It's also very visually unappealing to look at. It causes a lot of visual pollution. There isn't much going for the coal industry right now. As you can see from the graph, coal accounts for nearly 25% of the US's production. However, it counts for 0% of the investment. This again ties back to the fact that no one's willing to invest in coal based on the fact that it's seen as financially unviable. Back in 2013, the projections of coal demand were said to be on the rise. However, right now, in 2017, you can see that the demand is flatlining and not many people, there's not much of a demand rather for coal.
Hi, I'm Mishman Aziz of Team 4, and I will be talking about economic analysis of replacing coal with natural gas. So natural gas prices are low and gas storage levels are at all-time high. That, coupled with the need to cut carbon pollution, has more of the power generation market switching from coal to natural gas. The decline of coal can be attributed to increased regulation on carbon emissions and technology that has reduced pollution, that has reduced the cost of competing energy sources. In recent years, the Clean Power Plan has been replaced into effect. This act affects new rules, regulations, or standards that will reduce carbon emissions from power plants, considering the environmental impact that may leave carbon footprints. Options with the act of cutting emissions include investing in renewable energy, energy efficiency, natural gas, nuclear power, and shifting away from coal-fired power. Several factors have helped the decline in natural gas prices. Among them is that the better tools and technology have allowed more complex wells to be completed. While natural gas is more expensive to drill, these wells have increased productivity and efficiency, lowering the market price. These efficiency gains have allowed natural gas to remain profitable and have done little to deter production. In 10 years, coal consumption declined by 8%, while the production of natural gas have increased 6%. So, at what price levels do we start to see coal to gas switch take place? Coal has been preferred source of cheap energy, but for falling natural gases prices that have stabilized below $2.50 per megabillion BTU, making natural gas a competitive source of power plants. Natural gas replacement is dependent on the region, with the Midwest and Southeast showing the highest potential of coal to gas switching. Some Southeast states sources expensive Appalachian coal and have the advantage of few pipeline constraints and making them an ideal location to switch to gas. While in the Midwest, economic dispatch and plenty of spare capacity allows for easy switching to the cheaper energy alternatives. Because of the limited alternatives of natural gas consumption or production, even small changes in supply or demand over a short period can result in large price movements. Increase in supply and decreases in demand generally results in lower prices, and decreases in supply and increase in demand tends to lend to increases in prices. As you can see in the in this graph, you can see the supply and demand of natural gas production along with natural gas consumption and natural gas production over here, and you can see the general trend along over here with the green line and the red line. Also, there are three major supply side factors that may affect prices on the amount of natural gas production. It's dependent on the amount of natural gas produced, level of natural gas in storage, and volumes of natural gas imports and export. Three major demand side factors that affect prices are variation in winter and summer weathers, level of economic growth, and availability and prices of competing fuels. So, according to the EIA, natural gas represented 28% of U.S. energy consumption in 2012 and is expected to grow to 30% by 2040. This increase in natural gas production and consumption has helped both the workforce and economy. Today, the natural gas industry supports nearly 3 million jobs and adds about $385 billion to the national economy each year. The development of shale resources through hydraulic fracturing supported 2.1 million jobs in 2012, and continued development is expected to boost that number to 3.9 million jobs by 2025. And development of shale resources added $284 billion to U.S. gross domestic product in 2012, which is GDP in 2012, a figure expected to grow to $533 billion by 2025. On the state and local level, taxpayers actually saved $720 million on public electricity and natural gas expenditures. Not only is natural gas benefiting the workforce and economy, but is also benefiting the environment.
Hi, my name is Gilad Metro, and I'll be discussing natural gas and its impact on the environment. Although natural gas exploration and drilling often gets a bad rep, the benefits far outweigh the drawbacks in comparison with current coal-fired power plants. We can see improvements in areas such as global warming, air pollution, and emissions reductions, which I will discuss now. Natural gas, like coal, is a fossil fuel. However, natural gas is much better for the environment in comparison to coal, and the effects can be seen in greenhouse gas emissions. With global warming concern at a 3-decade high in the US, with roughly 45% of Americans believing it to be a major issue, natural gas could play a major role in solving the problem. Natural gas emits 50 to 60% less carbon dioxide when combusted in a new, efficient natural gas power plant compared with emissions from a typical new coal plant. Considering only tailpipe emissions, natural gas also emits 15 to 20% less heat-trapping gases than gasoline when burned in today's typical vehicle. As you can see from the graph, greater use of natural gas resulted in the lowest U.S. carbon emissions since 1992. Coal has long been a reliable source of American energy, but it comes with tremendous costs. When coal burns, the chemical bonds holding its carbon atoms in place are broken, releasing energy. However, other chemical reactions also occur, many of which carry toxic airborne pollutants and heavy metals into the atmosphere. These toxins include mercury, sulfur dioxide, nitrogen oxides, and particulate matter. Some other harmful pollutants include lead, cadmium, and volatile organic compounds, also known as VOCs. With the enactment of the Clean Air Act and the Clean Water Act, conditions have improved, but a full switch to natural gas from coal would expedite the process immediately. Cleaner burning than other fossil fuels, and especially coal, the combustion of natural gas produces negligible amounts of sulfur, mercury, and particulates. Additionally, burning natural gas does not produce nitrogen oxides, which are a major contributor to smog. The Department of Energy analyses indicate that every 10,000 homes powered with natural gas instead of coal avoids the annual emissions of 1,900 tons of NOx, 3,900 tons of sulfur dioxide, and 5,200 tons of particulates. Along with reduced emissions, many developments have been made in regards to drilling. New drilling and natural gas recovery technologies significantly reduce the land area that is disturbed to develop oil and gas resources. Horizontal and directional drilling techniques make it possible to produce more natural gas from a single well than in the past, so fewer wells are necessary to develop the same amount of natural gas. Although hydraulic fracturing has some negative effects on the environment, recent strict safety regulations in transportation and distribution are helping to minimize these effects. Some other exciting benefits that natural gas offers can be seen from the recent breakthrough in particulate matter concentration in China. After enacting stricter environmental regulations, China's particulate matter concentration has dropped a record 32% in just 4 years. The only time that the United States saw a drop like this was over a 12-year span from 1970 to 1982. This was mostly due to the Clean Air Act of 1970 and the invention of the catalytic converter. China has recorded extraordinary gains in life expectancies due to this complete switch to natural gas-fired facilities. The roughly 20 million residents in Beijing would live an estimated 3.3 years longer, while those in Sichuan would add 5.3 years and those in Boding 4.5 years. This research also suggests that these improvements in life expectancy would be experienced by people of all ages, not just the young and old. A report on the nation's power grid reliability published by the Department of Energy in August of 2017 found that natural gas has been the driving factor in pushing nuclear and coal plants toward retirement. Currently, the wholesale electricity market is functioning and designed even though there are pressures and threats to its health going forward, the report said. And while renewables have made it harder for traditional power sources, the report said, natural gas has played a major role in changing the makeup of the nation's energy supply. Cheap natural gas prices have made other forms of power that have long dominated less economic. Next, we will discuss what's driving this change.
Hello folks, my name is Zach Goulet, and I will be here to kind of help you outline to you exactly how we can make this conversion happen from coal to natural gas, and exactly what conditions currently are driving this transition. So just to reiterate kind of what's going on, the transition is motivated by economics and environmental standards. Basically, emissions are a problem in today's current day. People are concerned about it. Things like federal incentives, state renewable standards, and whatnot are driving the ability for these plant owners to transition to natural gas. And the reason why natural gas is their main thing they're thinking about is because of its cheapness and economic viability to compete with a coal plant. And just as you can see here, coal emits some pretty bad particulate matter and whatnot into the air, and you kind of a graph outlining the part of mortality probably caused by it. Just showing there is a lot of motivation and driving force behind these environmental standards. So, from from a current standpoint, pretty much these environmental standards, to implement them, there's really three options, two of which are really concerning to this project. But one is they can install these more expensive scrubbers and whatnot to make their emissions go down, and these tend to be very expensive and not completely desirable to the plant owner because it will degrade the economic viability of their coal project. So the other two options are to completely scrap a current coal plant that is pretty much going to be causing problems emissions-wise for years to come, and instead build a natural gas plant, or where this is kind of what I'm going to delve more into, you can pretty much upgrade a current coal plant, its boiler system, to fire natural gas instead. And as I said, a lot of the forces for the cheapness of natural gas are making this a very desirable option. And it also is worth noting that utilities already have the transmission lines and water close by in order to make this happen. So what makes something a great candidate to transition over? So these tend to be on the East Coast, these plants. They tend to be low in capacity or generation capacity for the reason being that natural gas is easy for peak load hours to turn on and off. So these tend to be desirable for a plant owner to change around. They tend to be very old, on the 50 to 60 year scale, and are easy to transition over because pretty much right now their current systems in the older plants are expensive to operate and they're not as efficient. So these tend to be the best candidates, and like I said, they're on the East Coast and small generation capacity. So from a plant owner's perspective, say I'm thinking about this transition and I want to make it happen. What I would do is hire an in-house team of engineers to kind of come in and do a cost economic techno analysis of the project. And what they're going to come back with is pretty much the advantages and disadvantages, and I'm very much broadening this thing out, but it's a really a case-by-case basis, but they're going to come back with advantages and disadvantages of transitioning the plant from coal to natural gas as its primary fuel for electricity generation. So say they do decide to make this happen. It's pretty much 2 to 4 years before you go from the study analysis to delivering the equipment and installation. As I said, this is a heavy case-by-case basis, and a big thing to take into note is new equipment versus just modifying current equipment. So a boiler for a coal plant for coal source of energy is significantly different than natural gas. There's big questions whether or not you need completely new equipment or just simply upgrading what you currently have. And just to kind of show an example, using a heat mass transfer program, a company like Lipton, what they do is they specifically look at the boiler system of the current coal plant and opportunities for upgrading. They pretty much look at the current heat characteristics and transition it to natural gas, maybe what effects will happen. My point is there's definitely, this is currently happening, the transition, and there's people handling these study analyses. So just some big considerations when transitioning to natural gas, and something that I thought was very interesting that I thought natural gas was more efficient, but it turns out that when you're specifically doing a CTG or a coal to natural gas plant, the efficiency tends to either go down or stay about the same with a little bit of losses. And this tends to be this tends to be because natural gas is a significantly different fuel than coal. Heat transfer properties are very different in that it's mainly convective due to its gas properties, while coal tends to be more of the radiative. So what is a big consequence of this? Your current coal plant is built around a system dealing with the heat transfer characteristics of coal. When you introduce natural gas per se as the main fuel source, your equipment before is now going to be susceptible to different heat properties, and you're going to get possible overall degradation. And you have to plan very strategically around the new fuel you'll be firing. This is a big thing to take into consideration for these CTG plants. So yeah, just to reiterate, you do have some big consequences when converting, and just it's a big thing that factors into these studies when transitioning over from coal to natural gas. Pretty much as I've said, so the overall the overall transition is a very tricky process. You are using a fuel with completely different properties for the most part to generate electricity. Kind of to show here, this is a coal plant versus a modern day natural gas plant. Clearly they don't look the same, so making a plant like this able to use natural gas is not a cut and dry process. That's more so of the conversion background. But to kind of give you an idea, you might be saying, why is this still happening? Well, conversion is and can be accomplished and still be accomplished, mainly because these emission standards are driving owners of coal plants to explore new options in order to maintain their production and economic viability of their plant. And pretty much right now, a big source of this to address these emission standards is to transition your coal plant to a natural gas plant. Natural gas being a flatline price for the last few years at the cheap sector, around $3 or a little under. And pretty much your older plants in the East Coast tend to be good conversion participants. And natural gas, the coal to natural gas plants are definitely occurring, and it's a good property going forward.
Hi, I'm Scott. So in today's presentation, we started by taking a look at coal, what its current position is on the market, and how it's affecting our environment. As you've seen, coal has been a very effective way for us to get energy, but it is also affecting our world as we know it. Global warming, any damage that we can have to the plant itself, and it is basically not going to be sustainable for much longer. So then we took a look at the economics of natural gas and why it's a suitable replacement for coal. And as you've seen, it's already being changed to a more natural gas focused economy, and we're having success already. Then we moved on to the environmental aspects of natural gas, and we looked at the actual chemistry behind why it will actually work better than coal as a source for energy. It'll cut down on global warming and still be a viable solution. Then, finally, we talked about implementation and how it's already being done to change our energy source from coal to natural gas. We've also looked at some neat tricks in how that we can make the implementation go over easier and faster. So, coal. It's been our nation's energy source for hundreds of years, rather. We have evidence to suggest that Native Americans were even using coal as an energy source as early as the 1300s for pottery and other sources of heat. Colonists first had coal mines in the 1700s, so we've been running off of this for centuries, as it were. But just because it's been this way for this long does not mean that coal will be a good solution for the future. We've seen the effects that it's had from the environment, and we need a way to come up with something that'll work. And that is natural gas. And why does this matter to us? Well, many of us are going to end up with jobs in this exact field, and you're going to need to know the terrain. Sure, coal has been the way that maybe your parents or ancestors who've been engineers have worked, but that's not going to be the way much longer, as we've seen. We need a new way to keep the country powered, and even if you don't end up in this field, you're going to have to pay an electricity bill every so often. So you're going to need, or at least want to know where it's coming from in order to, say, have a voice when it comes to politics or wherever natural gas and energy sources will become important. So, if you want to keep the lights on, the stove lit, why not natural gas? Thank you.